In our previous lesson, we spoke about the roots of quadratic equation. And then what we did was we came out with a table. Let me show you that table real quick. Okay, so we used this table and then we said that when you have b squared, okay, you have b squared minus 4ac to be greater than 0. That means that you have two real distinct roots. When it is equal to 0, it means you have two real and equal roots. And when it is less than 0, you have 0 real roots. So we are going to apply the same thing. So if you haven't watched my video on, this is the topic, okay, roots of quadratic equation, I suggest you watch it. Okay, but if you know already, then no problem. You can just continue with this video. So let's go to where we are going to work today. Okay, all right, so an intersection of a line and a curve, and the curve under consideration is a quadratic. Okay, we are not going to talk about cubic. We will highly concentrate on quadratics. Well, so first situation, okay, your first situation is that the line, this line, okay, and then the curve will intersect at 2 points. Okay, so let's call this A and then this B. It's possible. So when that happens, then we know that we have 2 points of what? Intersection. No problem. This came about because the line cuts the curve at 2 what? Distinct points. And we know that when a solution has 2 distinct roots, then that solution would certainly have b squared minus 4ac to be greater than 0. Okay, because this produces 2 distinct roots. Okay, we say 2 distinct because A is not the same as B, so they are distinct, they are different. Okay, you get 2 different roots. All right, now let's look at the situation 2, where the curve and the line meet at only 1 point. So this is situation 2. Well, the curve and then the red line are meeting at 1 point, say point A. Okay, so what are the facts can we see from this sketch? Well, we can see that there's only 1 point of what? Intersection. Then this line touches the curve at only 1 point. That is something we can see. But what does that mean? Well, this means that the line is what? Tangent. Okay, the line is tangent to the curve. Well, when it is tangent, it means it is cutting at one side. That means that the two, for example, this quadratic equation is this quadratic equation is ax squared plus bx plus c, and then it has intersected the line. Let's say the line is y equals mx plus c. Okay, and then we solve for x, and the first, for every quadratic that you solve, there are 2 roots. Okay, we expect to be 2 roots, but let's say the first one is answer is A, and then the second one too, answer is what? A. This means that you are getting 2 answers. Okay, granted the answers are 2, but they are the same. So we say that it's 2 equal roots. Okay, because the answers are actually the same. If this is the scenario, then we use what we call b squared, okay, b squared minus 4ac equals 0, because this identity gives us 2 equal roots. Okay, so whenever you hear 2 equal root, we want to use this formula. Now let's look at the last one, where the quadratic curve and the line do not even meet at all. what happens there? That is situation 3. So clearly our quadratic and then the line are not meeting at all. So what are the facts here? Well, there is 0 points of intersection. They are not meeting. So the line and the curve does not meet. Now if they do not meet, it means that there are no real roots, okay? There are no real solution, because when we equate the quadratic, okay, the quadratic to the line, that is where we can solve for our answers, right? But the point is they do not meet. If they do not meet, it means the answer does not exist. And if it does not exist, then it means that they do not meet. And that means we should use this is less than 0. Now, this is possible because when you solve under the square root sign, you get a negative answer, okay? So let's say negative 10. And since the square root of a negative number does not exist, it merits this identity. So whenever we are solving and then we are told that, well, it has 0 roots, then that means that if it has 0 roots, it means that we should use this formula, okay? B squared minus 4AC is less than 0. So at this point, I want us to solve questions to see how we actually apply this. So this is our first question. Let me change the color to black. Black is good. Now find the values of k for which this line and that quadratic is what? Tangent. Well, tangent means they meet at one point. If you've forgotten, let's go back and I'll show you something. See, so we said that has to be what? Tangent, okay? Because it's meeting at one point. And one point means 2 equal what? Roots. So let's go back. Oh no, that's not that. Okay, good. So only with what? Tangent. So we know that if for tangent, we know that we are interested in this identity. Okay, that is the first thing we put down. Well, we have the line to be this, and then the curve to be that. Well, it could be seen that they both have y, so we can easily equate, right? So that will give us, oh no. So that will give us 2x squared plus x plus 3 equals kx plus 1. Well, let's put everything on one side of the equation. Okay, so this will give us 2x squared, then we have plus 1 minus k, okay, x plus 2 equals 0. All right, so this is what we have. I hope we are right. Yeah, I guess we are right. Then the next thing is that we have already said we are going to use this. So that is what we do use. Now A is 2, B is 1 minus k, C is 2, okay? So we have B squared, so that would be 1 minus 4, k squared, okay? Then minus 4 into A, and then C is also 2 as well. All right, equals 0. So this will be 1 minus 2k plus k minus, because this will be 16, right? Good. I hope it's 16. Well, then we have, now this is k squared. Yeah. So we have k squared minus 2k minus 15 equals 0. All right, so we can solve this. K here, k there. Well, we want factors of negative 15 that when you add, you will get what? Negative 2. Well, that has to be, I think that's negative 7 and then 5, if I am not mistaken. Why don't we go with, that's not true. Let's go with negative 5 and then 3. Yeah, I think that is rather true. Because when you multiply, get negative 15. When you add them up, you get negative 2. That is true. So it means that k minus 5 is equal to 0, or k plus 3 is equal to 0. That gives us k equals 5, or k equals negative 3. Well, what we have done means that when the values of k are this or that, we can say that our line and then the quadratic would meet at only what? 1 point. It means they are tangent. Okay, so that is when the value of k is, when k is either 5 or negative 3. Okay, if it is not 5 or negative 3, then it means that they can meet at more than 1 point. All right, now let's solve another example and see how we can apply our knowledge of a line and then a quadratic meeting. So this is the example we want to look at. It says that we should find a set of values for k for which the line, this line, cuts this curve at what? 2 distinct points. So that is the clue, 2 distinct points. So for 2 distinct points, we know that b squared minus 4ac should be greater than 0. Okay, has to be positive. Well, the first thing that we want to do is to, well, rewrite our curve and then the line. Then this is y, that is why we can easily equate and then solve for x. So we have x squared plus kx plus 2 is equal to 3x plus 1. Then let's move everything to one side. So that would be x squared plus, okay, then plus 2 minus 1 equals 0. Well, this gives us, good. So at this point, we want to factor out x, okay, plus 1 equals 0. Oh, I said equals 0. No, that is not true. It should be greater than 0. I mean, we have already established that fact here. So, okay, we've not read there, sorry. It's actually equal to 0 since we are grouping like terms. Okay, now we want to use this argument, okay? All right, so what is our A? A is 1, B is that, and then we have C equals 1, okay? So B squared, that would be this whole thing squared minus 4 into A into C. But what is C? C is also 1, right? It's greater than 0. Okay. So this will give us k squared minus 6k plus 9 minus 4 is greater than 0. So k squared minus 6k plus 5, yeah, greater than 0. Now, what we do is that we want to solve this beautifully. So we have k here, we have k there, but factors of k, well, sorry, factors of 5, when we add, we get negative 6. Well, that has to be negative 1 and then negative 5. because, well, I don't think there's any other pair that can give us what we want. Okay, now what this means is that, look, you want to find a desired region, a region which will be greater than what? 0. Do not solve and say that, well, k is greater than 1 and then k is greater than 5. This is not true. Not true. And I'll tell you why. Sketch it first. Okay, you don't need to sketch a perfect quadratic curve. That's not what the question is asking you to do. You are just solving an equation. But remember that the sign of the k here is positive. It means that the quadratic curve is U-shaped. It's U-shaped like this. That's all. That's all you need. Then the zeros of this equation will be 1 and 5, right? Yeah. So you have 1 here, and then you have 5 there. Okay. Now, what you want is, remember that this is the positive, this is positive. Any part that is below the x-axis is negative. But we want a positive. It means we want this part and that part. That is what we want. That would mean that you want x values to be what? Going this way, and you want the x values to be going that way. Well, for x values to go this way, okay, that would mean that your x should be greater than what? 5. For x values to go that way, your x should be less than what? 1. That is a fact. But the thing is that we are not dealing with x, we are dealing with k, so that is what we will use. So we will say that k is less than 1, and then k is greater than 5. Like I said, compare. Your k is greater than 5. This one is true. But this one, not true. You see? That's why I said, always sketch it. Okay, when you sketch it, you will be always right, because you will know the behavior of the curve, and you know the desired region to go for. All right. Okay, so that is it. Let's look at our final question. All right, so we have this. My interest is on it says that they do not what? Meet. That is the most important thing. So for curves that do not meet, okay, if they do not meet, it means that there is no real solution. Okay, and if there's no real solution, then b squared minus 4ac is actually less than 0. Well, let's write out there. Oh, this is blue already, so let's use like okay, so y is equal to mx minus 5. That's for the line, and the quadratic is x squared minus 5x plus 4. Well, it could be seen that we have y here, we have y there, so we can just equate them. So that would mean we have x squared minus 5x plus 4 equals mx minus 5. Okay, so this would give us x squared, then we have minus 5x minus mx plus 4 plus 5 equals 0. Okay, so we have x squared, then we have plus negative 5 minus mx out plus 9 equals 0. Well, we said they do not meet. That means that we are working with this identity. Well, your A is 1, the B is negative 5 minus m, and the C is 9. So that means that we have b squared. Okay, why am I still writing b squared? All right, so we have b squared, which is negative 5 minus m squared, 9 minus 4 into A, which is 1, into C, which is 9, should be less than 0. Well, so we have 25, then plus 10m plus m squared minus 36 is less than 0. All right. So that is it. Then we can write it well like m squared, then plus 10m, then 25 less 36, that should give us negative 11, right? Yeah, I hope that is true. I think that is true actually. Okay, so we have this and we can solve for m. This is a nice quadratic setup. M is here, m is there. Well, what you do want is you want factors of negative 11 when added will give you a positive 10. Well, that would be, 11 is a, a prime number, so it has only two factors, itself and 1. So you have negative 1 and then positive 11, I think. Yeah, that is possibly the only combination that can work this thing correctly for us. Okay, but I've been telling you that do not say, okay, at this stage you solve with that sketch, you'll be wrong, and I don't want you to be wrong. Okay, I want you to get a perfect score in your exam. So just sketch it. It will take few seconds. Now it is U-shaped because of this, but if we had this whole thing, okay, if we had this whole thing, go back. If we had this whole thing, all right, to be as negative m squared plus 10m minus 11 is less than 0. Since if we had this to be negative, then the curve would have been like that. Okay, put that one in your mind always. Well, it's not negative, so we will work with this curve. So let's clean this one. Okay. All right, now the zeros of what we have here, okay, the zeros of what we have here will be negative 11 and then 1. But look at it. We want the part that is negative. Well, if you have a curve like this is negative, this is positive, this is positive, okay? All the part that is above the x-axis is positive, and all the part below is negative, okay? So we are looking for, this is the part that we are looking for, okay? And this part will mean that you want all your x values to be going that way, and you want all your x values to be coming that way, okay? And for this to work, it means your x should be what? Greater than negative 11, and then your x should be less than 1, okay? That is what you want. But remember that we are not dealing with x, we are dealing with m. So that means that m is greater than negative 11 and m is less than 1, okay? So that is the values of m for which the curve and the quadratic will not meet, okay? Well, if you want to put them together, then you have m is less than 1, but m is greater than negative 11, of course. So we can get something like this, which is also perfectly fine, okay? So the clue is that always pay attention to this part, whether they will say that they are meeting, okay, these are meeting, or they are not meeting. That is the most important part. If they meet, okay, and then while they have two real roots, then you know that you are going to use this identity, that is, they have two real distinct roots. If they meet and they have two equal roots, then you are using this identity. If they do not meet at all, then you are using this identity. Please put these three in mind. They will really be of help if you can commit them to memory. All right, see you in the next lesson, and always subscribe to my channel for more videos.